Yo. Hello. Thank you. Thank you. Let me try that again. Hello. Thank you. How are you? Eight hundred and 851. What's that? 851. Hmm. 851. Oh, it's a prime number. It's a prime number. Yes, I love melons. Okay. Okay, we're up to 31. Exercise 31. "43 squared, 1,849. 89 squared, 7,921. 143 squared, 20,449. 306 squared, 93,636. 2,040 squared. 4,161,600. 52 times 57. 2,964. 106 times 113. 11,978. 208 times 203. 42,224. 1,004 times 993. Okay. $996,972. 10,004 times 9,995. Okay. $10,004 times 9,995. All right, so we've got to do 99,950,000 plus 39,980. $39,980. Okay, 99,689,980. All right. 87 times 9. 783. 3,486 times 99. 3,486 times 99. $345,114. 428 times 999. 427,572. Okay. 2,507 times 9,999. 25,067,493. 736 times 998. 734,528. 342 times 11. 3,752. 74 times 101. 7,474. 527 times 1,001. 527,527. 4,382 times 10,001. 43,824,382. 68 times 11. 748. Okay, now back to calculus. All right.
Where's it gone? Oh. Right here. Okay. All right, section 6. Find the area enclosed by the curve y equals x squared, take 4x and the x-axis and the lines x equals 0 and x equals 2. X squared take 4x, huh? Okay, so I visualize that it crosses at 0 and 2. Yeah, it's the parabola that passes through the origin and 2, 0. All right. That doesn't uniquely pin down the parabola, but it's that one. And we have to find Okay, so you have to integrate x squared take 4x dx from 0 to 2. The integral is a third of x cubed take 2x squared, a third of x cubed take 2x squared. Now sub in 2. Eight over 3 take 8. 8 over 3 take 8. So 2 and 2/3 take 8. So minus 5 and 1/3. And that has to be positive because it's talking about an area, so 5 and 1/3. So 5 and 1/3 is the area enclosed by the curve y equals x squared take 4x and the lines x equals 0 and x equals 2 and the x-axis. Find the area of the region again. Find the area of the region enclosed by the curve y equals x cubed and the x-axis and the lines x equals -2 and x equals 0. Okay, so that will be a negative area, which we have to then force to be positive. All right, so integrate x cubed dx, and we get 1/4 of x to the 4. 1/4 of x to the 4 evaluated from -2 to 0. Is 4. Okay, so 4 is the area of the region enclosed by the curve y equals x cubed and the x-axis and the lines x equals -2 and x equals 0. Find the total area of the region enclosed by the curve y equals x squared minus 4 and the x-axis. So this is a unit parabola, but translated vertically downwards by 4 units. Okay. It's just the same calculation. We have to integrate. Well, you need to actually find the roots first, and the roots would be 2 and negative 2. So integrate from minus 2 to 2, x squared minus 4dx. All right, so the integral is a third of x cubed minus 4x. And it's symmetric, so we can exploit that. A third of x cubed minus 4x sub n2 so 8/3 take 8, which is negative 5 1/3. And thus that'll be doubled, so in total it'll be 10 2/3. So 10 2/3 is the area of the region enclosed by the curve y equals x squared minus 4 between the lines. No. 10 2/3 is the area of the region enclosed by the curve y equals x squared minus 4 and the x-axis. Find the total area enclosed by the curve y equals x cubed from x and the find the total area enclosed by the curve y equals x cubed and the x-axis from x equals negative 1 to x equals 2. All right, so we have to split that up into 2 regions, but we can exploit the fact that it's an odd function. So we integrate it, so we have to integrate x cubed dx, which is 1/4 of x to the 4. The first part is to go from 0 to 2, 1/4 of x to the 4. Which is simply 4. So we put 4 away for later. And then we have to plug in 1. And that's 1/4. And so we add them together in this case. So we get 4 1/4. So 4 1/4 is the area enclosed by the y equals x cubed and the x-axis between the lines x equals negative 1 and x equals 2. You should improve your concentration. It will help you in your life because you will pay attention to your own life. Find the total area enclosed between the curve y equals x times x minus 3 and the x-axis. Okay, so This is a parabola that is opening upwards and is below the x-axis and has the roots 0 and 3. So we have to integrate its expansion from 0 to 3. Now, when we expand it, we get x squared minus 3x. So we have to integrate from 0 to 3, x squared minus 3x dx. Okay, so the integral is a third of x cubed minus 3 over 2 x squared now a third of x cubed minus 3 over 2 x squared. Now we just plug in 3. And that would be 9 take 27 over 2. But 27 over 2 is 13.5. So 9 take 13.5 is negative 4.5. But we want the positive version of that. So it'd be 4.5. So 4.5 is the area enclosed by the curve y equals x times x minus 3 and the x-axis. Hello. Okay, section 7. Is the last section, and it's areas between curves and lines. Find the area of the region enclosed between the curves y equals x squared and the line y equals x. Okay, it's that tiny slither that we are imagining which connects the origin to the point 1, 1. Okay, now the area bound, that triangle that we're visualizing has an area of a half. And let's see now. Alright, so we have to integrate x squared dx from 0 to 1. And when we do that, we get a third of x cubed, which evaluated from 0 to 1 is just simply a third. So really it's a half take a third, and that will give us the answer, which is 1/6. So 1/6 is the area of the region enclosed by the curve y equals x squared and the line y equals x. Find the area of the region enclosed between the curve y equals x squared and the line y equals 4. Okay. All right, how to do this? Okay, so 2, 4 on the right, negative 2, 4 on the left. So just evaluate it for 0 to 2, then double it, then subtract it from the rectangle, okay? All right, so integrate x squared dx from 0 to 2. And when we do so, let's see, that's a third of x cubed. All right, so sub in 2, and we get 8 thirds, but then we have to double it, so we get 16 thirds, which is 5 and a third. And then that has to be subtracted from what? That has to be subtracted from 16. Which is 11 and 2/3. No, it's not. That's 10 and 2/3. Okay, so 10 and 2/3 appears to be the area of the region enclosed by the curve y equals x squared and the line y equals 4. Find the area of the region enclosed by the curve y equals 6x, take x squared, and the line y equals x. Okay, so 6x take x squared. What's that? All right, that's a parabola that's opening downwards that goes through the origin and six. Now what? Okay, so it goes through the origin and 6, 0. And y equals x goes through the origin as well. All right, so we need that region enclosed by that parabola. Right? Correct. Okay? Okay, so how to do that? Okay, so integrate from 0 to 6, 6x take x squared dx. Okay, so we only need to plug in 6 when we integrate it, and when you integrate it, you get you get 3x squared take a third of x cubed. Now plug in 6. (108) take 72. 108 take 72 is 36. All right, so 36 is the area under that curve. Now, where does the curve cross? Like, where does it intersect with y equals x? So you have to solve x equals 6x take x squared. All right then, so 0 equals 5x take x squared. Right, so why isn't it the case that x is equal to 5? Right? 5. Okay, so what? So what? How do you do it? How do you do it? Hmm. But that wouldn't help you do it, though. Well, what you do is you find that triangle there, which you can do, and then you find the region to the right of it, and then you add those together, and then you subtract it from 36. You understand? Yes, I understand. All right. Okay. So that's kind of obvious. That would be 12 and a half, right? Okay. And then what about the region to the right? That would be the integral of 6x take x squared from 5 to 6. From 5 to 6. You get it? Yes, I get it. All right, so the integral of 6x take x squared dx is 3x squared take a third of x cubed. 3x squared take a third of x cubed. You already know that plugging in 6 gives you 36, so don't do that. Now just plug in 5. All right. Three times 25, so 75. Take 41 and 2/3, right? 75 take away 41 and 2/3. 33 and a third. That's way too huge for that. Hello. Alright, so this is not the best technique, so something better has to be developed for these. Okay. Alright. So now we do the next set here. (1,246) times 5. All right, so there's a noise, a very large noise. So continue. 1,246 times 5. 6,230. 3,648 times 25. 91,200. 728 times 125. 91,000. 176 times 625. Did you hear it? I heard it. 176 times 625. 11,000. No. (176 times 625). That's 110,000. (864 times 128). Okay, 864 times 128. That's strange because obviously the form on the left is 2 powers of 2 concatenated together, and that's a power of 2 on the right. So what do you actually do? Just proceed with the algorithm. So why is it not 11,592? Because that's too small, that's why. Alright, fine. To make a correction then. Alright, 864 times 128. 110,592. All right, there. Hello. $68 times 15. 1,020. 84 times 75. 6,300. 132 times 45. 5,940. 224 times 175. 39,200. 2,400 times 375. 2,400 times 375. Okay, so just do 24 times 375 and stick 2 zeros on the end, please. Well, 24 times 25 is 600, isn't it? Okay, and then just take away 600 from 24 times 400. Well, 24 times 400 is 9,600. So take away 600, you get 9,000. Stick 2 zeros on the end, you get 900,000. All right. Now we can do the last chapter here. Hello. And the last chapter is exponentials and logarithms. And so that's what we're going to do today. Now, section 1 is exponential functions. Exponential functions. Find the value of y equals 5 times 3 to the x when x is equal to 0. Well, 3 to the 0 is just simply 1, and therefore the value is 5. So 5 is the value of y equals 5 times 3 to the x when x is equal to 0. Find the value of y equals 2 to the x when x is equal to negative 3. 2 to the negative 3 is 1/8. So 1/8 is the value of y equals 2 to the negative x when x is equal to 3. Solve 2 to the x equals 32. So we know from experience that x is equal to 5. So 5 is the solution of 2 to the x equals 32. Solve 5 to the x plus 1 equals 125. We know from experience that 5 to the 3 is 125, and thus x is equal to 2. So x is equal to 2 when 5 to the x plus 1 is equal to 125. State the equation of the asymptote to the curve y equals 2 to the x plus 3. The asymptote to the curve y equals 2 to the x is the x-axis, the horizontal line defined by y equals 0. But in this case, adding 3 to the function translates it vertically upwards by 3 units, and thus the answer is y equals 3. So y equals 3 is the horizontal asymptote to the function y equals 2 to the x, all at 3. All right, next section here. Next section, y equals e to the x. Now, I have to be so careful with this, because I frequently get this wrong and I don't know why. I do not know why. Even though it's just so obvious, right? Oh, let's just try it. Let's just try it. Okay. Differentiate y equals e to the 3x. All right. I really do think that it's just simply dy by dx equals 3e to the 3x, but I could be wrong. So we have to check. Hello. Oh no, that's right. Okay, we're on a good roll. Differentiate y. All right, so I have to actually repeat it. Hold on 1 second. Dy by dx equals 3e to the 3x when y is equal to e to the 3x. All right, next up. Next up. Differentiate y equals 4e to the negative 2x. Dy by dx equals negative 8e to the negative 2x. Dy by dx equals negative 8e to the negative 2x when y equals 4e to the negative 2x. Find the gradient of the curve y equals e to the x at the point when x is equal to 0. Did you read it? Yes, it says y equals e to the 2x. Alright, okay. Find the gradient of the curve y equals e to the 2x at the point when x is equal to 0. dy by dx equals 2e to the 2x, sub in 0, and we get 2. Alright, so 2 is the gradient of the curve y equals e to the 2 is the gradient of the curve y equals e to the 2x at the point when x is equal to 0. Find d2y by dx squared when y equals e to the 5x. dy by dx equals 5e to the 5x. So d2y by dx squared equals 25e to the 5x. So d2y by dx squared equals 25e to the 5x when y equals e to the 5x. Find the exact gradient of the curve y equals 3e to the x when x is equal to 1. Okay, dy by dx equals 3e to the x. Let x equal 1. Then the answer is 3e. So 3e is the gradient to the curve y equals 3e to the x when x is equal to 1. Okay, section 3. Exponential modeling. A population is modeled by p equals 200 times 1.1 to the t. Find the initial population. The initial population will be when t is equal to 0, and thus p equals 200 times 1.1 to the 0. 1.1 to the 0 is just 1, and therefore initial population is 200. So the initial population is 200 when population is modeled by p equals 200 times 1.1 to the t. The value of a machine is modeled by A equals 8,000 times 0.9 to the t pounds after t years. Find its value after 2 years. Alright, so A equals 8,000 times 0.9 to the 2. 0.9 to the 2 is 0.81. 0.81 times 8 is 6,480. No, 0.81 times 8,000. 0.81 times 8,000 is 6,480. So £6,480 is the value of the machine whose value is modeled by A equals 8,000 times 0.9 to the t after 2 years, right? A temperature is modeled by theta equals 20 plus 60 e to the negative 0.1 t. State the limiting temperature T as T becomes large. Okay, so as T becomes very, very large, the e to the negative 0.1 t factor will approach e to the negative infinity, which approaches 0, and thus we can ignore that term altogether, and so the limiting temperature will be 60. So the limiting temperature is 60 for the temperature theta, which is modeled by theta equals 60 plus 20 times e to the negative 0.1 t. Hello. No, that's actually incorrect. I read it incorrectly. All right, so I've got to do it again. A temperature is modeled by theta equals 20 plus 60 times e to the negative 0.1 t. Find the limiting temperature as t becomes large. All right, so copy and paste the same reasoning from before, and then we can ignore that entire term, 60 e to the negative 0.1 t, and we just get theta is equal to 20. A mass is modeled by m equals 50 times t to the... A mass is modeled by m equals 50 times 2 to the negative t over 10 grams after t hours. Find the amount of mass after 20 hours. Alright, so subbing in 20, we can see 2 to the negative 20 over 10, which is 2 to the negative 2, and 2 to the negative 2 is 1/4, and so it would be 1/4 of 50, which is 12.5 grams. So 12.5 grams is the mass of a mass which is modeled by m equals 50 times 2 to the negative t over 10 grams, where t is the number of time in hours that has elapsed, and t is equal to 20 hours. Okay, next. A colony of 300 bacteria increases by 5% per hour. Write down a model for P, the population, after T hours. Okay, so P equals 300 times 1.05 to the T. So P equals 300 times 1.05 to the T is a model of the population P of the number of bacteria whose initial count is 300 and which grows at a rate of 5% per hour. Section 4, logarithms. Evaluate log base 3 of 81. The answer is 4. 4 is log base 3 of 81. Evaluate log base 2 of 1/8. The answer is -3. -3 is log base 2 of 1/8. Evaluate log base 16 of 4. The answer is 0.5. 0.5 is log base 16 of 4. Solve log base x of 49 equals 2. The answer is 7. So x is 7 if log base x of 49 is equal to 2. Evaluate log base 5 of 5 and log base 7 of 1. Log base 5 of 5 is 1 and log base 7 of 1 is 0, and therefore the answer is 1. So 1 is the answer to log base 5 of 5 and log base 7 of 1. No, 1 is the answer to log base 5 of 5 plus log base 7 of 1. Okay, section 5, laws of logarithms. Evaluate log 10 8 plus log 10 5, take log 10 4. Okay, so using the laws of logarithms, this would be log base 10 of 8 times 5 all over 4. Or rather, log base 10 of 8 times 5 over 4, which is log base 10 of 10, which is 1. So 1 is the answer to log base 10 of 8 plus log base 10 of 5, take log base 10 of 4. Write 2 log base 3 of 6, take log base 3 of 4 as a single logarithm and then evaluate it. Okay, 2 log base 3 of 6 is log base 3 of 36, and log base 3 of 36 take log base 3 of 4 is log base 3 of 36 over 4, which is log base 3 of 9, which is 2. So 2 is the evaluation of 2 log base 3 of 6 take log base 3 of 4. Come on, try again. Try. Given log base a of 2 equals p, express log base a of 8 in terms of p. All right. So log base a of 8 is log base a of 2 to the 3, which is 3 times log base a of 2, which is 3p. So 3p is log base a of 8 written as an expression in terms of p when log base a of 2 is equal to p. Solve log base 2 of x plus log base 2 of 3 equals log base 2 of 12. Okay, so just move log base 2 of 3 to the right hand side, and then that's log base 2 of 12. Take log base 2 of 3, which is log base 2 of 4, which is 2. And so log base 2 of x is equal to 2. And so what could x be? 2 to the power of what is equal to 2? The answer is 1. Okay, so the answer here is actually 4. X is equal to 4. So 4 is, no, wait, that could have been done way easier. So 4 is the answer. 4 is what x is when log base 2 of x plus log base 2 of 3 equals log base 2 of 12. Okay. Write log base 2 of 40, take 3 log base 2 of 2 as a single logarithm. Okay, that's log base 2 of 40. Take log base 2 of 8, which is log base 2 of 40 over 8, which is log base 2 of 5. So log base 2 of 5 is the single logarithmic expression of log base 2 of 40. Take 2 log base 2 of 3. No. Log base 2 of 40, take 3 log base 2 of 2. Yes. All right, section 6. Section 6. Solving equations using logarithms. So 5 to the 2x equals 25. We already know that the answer is 1, just through experience. So x equals 1 when 5 to the 2x equals 25. So 4 to the x equals 8. 4 to the x equals 8. We already know that the answer is 3 over 2. We don't need logarithms. X equals 3 over 2 when 4 to the x equals 8. Solve 3 to the x equals 20, giving your answer as a single logarithm. We take logs of both sides, in particular log base 3. So x equals log base 3 of 20. Log base 3 of 20 is a single logarithmic answer to 3 to the x equals 20. Solve 2 to the 2x, take 2 times... Solve 2 to the 2x, take 6 times 2 to the x plus 8 equals 0. Okay. Let y equal 2 to the x. Then rewrite the whole equation as y squared take 6y add 8 equals 0. Then we know that y take 4 times y take 2 equals 0. So y equals 2 or 4. So 2 to the x equals 2, or 2 to the x equals 4. In the first case, x equals 1, and in the second case, x equals 2. So x equals 1 or 2 for the equation 2 to the 2x times. So x equals 1 or 2 for the equation 2 to the 2x takes 6 times 2 to the x plus 8 equals 0. Solve 3 to the 2x, take 4 times 3 to the x plus 3 equals 0. Similar technique to before. Let y equals 3 to the x. Then the equation becomes y squared take 4y plus 3 equals 0. Solve by factoring. Y take 3 times y take 1 equals 0. So y equals 1 or 3. So 3 to the x equals 1 or 3 to the x equals 3. So x equals 0 or 1. X equals 0 or 1 for the equation 3 to the 2x, take 4 times 3 to the x plus 3 equals 0. Section 7 is working with natural logarithms. Evaluate ln of e to the 4. The answer is 4. Four is the evaluation of ln of e to the 4. Evaluate e to the ln of 7. E to the ln of 7, in other words, e to the natural logarithm of 7, I have a feeling that it will just simply be 7, won't it? Well, I'll just say x equals e to the ln of 7 and take the natural logarithms of both sides. So ln of x equals ln of 7, and so x is, of course, 7. Hello. Yes, e to the ln of 7 is 7. All right. Solve e to the 2x equals 9, giving your answer as a single logarithm in its simplest form. If e to the 2x equals 9, then natural logarithms of both sides. So 2x equals ln of 9. So x equals if 2x equals ln of 9, then x equals a half ln of 9. So x equals ln of 9 to the half, so x equals ln of 3. It's a good question. Solve ln of x equals 3. Exponentials of both sides. So x equals e to the 3. X equals e to the 3 for ln of x equals 3. Solve ln of 2x take 1 is equal to 0. Exponentials of both sides. So 2x take 1 equals e to the 0. So 2x take 1 equals 1. So 2x equals 2. So x is equal to 1. X equals 1 when ln of 2x take 1 is equal to 0. Hello. All right. All right, and that finishes it for today then. So I've got to mark it. All right, that's all good. All good. Okay, all right.